All right, so part of me thinks that this is completely unnecessary to go through this again, but probably there's some stuff in here that you may or may not remember, so what the heck, it's worth it. Noah! Push your phone away! Push your phone away! Push your phone away!
When you do that, you look like Frenzy Randall from Rocket Man.
Don't know who that is. All right. So the first thing in your review, Marcella, is to remember where logarithmic functions come from. Okay.
It's the inverse of an exponent.
Right. So yes. So here's what happened in the world of math. They said this is the general form of an exponential function, right? This is exponential growth. And we know that since that is 1 to 1, it has an inverse, and the inverse looks like this. And the inverse of an exponential function must also be a function. And so therefore there must be some math function for that. So they go, well, here's how you find the inverse. You go y equals b to the x. How do you find the inverse of something? You switch the x and the y, so you rewrite this as x equals b to the y, and then you solve that for y. But unfortunately, we can't solve this for y because we can't take the yth root of both sides and expect to get something that makes sense. But again, we know from looking at the graph that this must exist. And so mathematicians never take no for an answer, and so they say, well, we're just going to make something up, and we're going to say, if I tell you that the log base b of x equals y, what I mean is this right here. This right here is this solved for y. So when you see log base b of x equals y, what you should think in your head is this little number down here is the base, and we're going to raise that to this power, and we're going to get this as an answer.
Which is weird, right away.
It is, and it bothers me very much.
Is log a number or is it a process?
It's an operation. It's like a plus sign or a times sign.
What does it mean?
It means this number raised to this power equals this number. Okay? So when you are faced with a problem like this,
Oh yeah, I remember how I remembered it. Base answer exponent.
base answer exponent. So what Mary is saying is this is the base, this is the answer,
Actually,
and we're right.
Wait,
What Raina said is this is the base, this is the answer, and what we're trying to find is the exponent. So this log thing Mary is asking us, 3, it's a way of asking 3 to what power is 81?
Do you know what
3 to the what? 3 to the
So
third.
How did you do that?
Because 3 times 3 is
So you're
9,
just gonna guess?
times 3 is 27, so that's actually wrong. It's 4, times 3 is 81. So yes, at this point we're just going to guess. Okay?
Exponent.
Okay, so this one is saying 25 to what power is 5?
No, 2.
25 to the 5th power?
1/2.
1/2. Okay? Because that means the square root, right? And since the square root of 25 is 5, the answer is 1/2.
Wait.
I need more food.
25 to the 1/2 power equals 5. Square root of 25 is 5, and then another way to write the square root is as to the 1/2 power. Okay, and then log base 10 of 0.001.
Is there a coincidence?
Yeah, because this is like tens, hundreds, thousands. This is 1/1000, and since this has 3 zeros, that's 10.
Negative 3?
It's going to be -3. Yeah, 10 to the third is 1,000. So 10 to the negative third is 1/1000.
Isn't it log of 10?
Yeah, if it doesn't say a base, then you just assume that it's base 10. You don't assume, you know.
Because then if it's not, you have to use the log.
Right, and then we can do that on the calculator. Okay, so let's get to the calculator part. Oh, here's some properties. It's funny, this is just exactly what we're doing in advanced algebra. Since these are based off of exponential functions, and you know that if you go x to the third times x to the fifth, what do you do with the exponents? you add them together and get x to the 8th. The same is true with logarithms. If you go log base a of x times y, since you're multiplying, you end up adding instead. Okay? Division, when you divide exponents, you subtract, and then if you have a power to a power, you turn it into multiplication. Okay? And there's two ways that I remember that. One is that a plus sign and a time sign look the same except one's been rotated. And a minus sign and a division sign look the same except one has a couple of dots. So that makes me remember that subtraction is division in the world of logs, and addition is multiplication. Okay?
What do you read this person?
It's almost April, that's so weird. That is weird. This is
March 24th, really?
So the national championship February was just like.
When is the national championship?
How's your bracket doing?
Terrible. I was going solid in my district until the lost. They gave us on grow.
Is the Final Four on that Saturday, the 5th?
How's
And
your
then is
bracket
it Monday the 2nd?
doing?
I have 3 teams in the Sweet 16, which is good, because there's 8 people, so you'd expect everyone to have 2 left. I got 3. Mr. US 4, Mr. Jensen has 3, Mr. Klinger is the first man out.
I was solid on that. That was bad.
Mr. Who? Mr. Trimble has 1 team left.
So once all your teams are out, you're done.
You're done.
So Mr. Pugh has a pretty good shot.
Yeah, because he's got 4 teams left. Yeah, you win more money the later you go. So Mr. Klinger won, like, he paid $30 and got back like 5.
So he didn't get any winners.
He did, but they didn't go very far.
What's the max you can win? You have
Um,
perfect bracket.
if all, I don't know.
There's no way you can get everyone.
Yeah, you can.
No, because
If they end up playing each other, and so some of them are doing that. All right, so log base 4 of 2 plus log base 4 of 32. Addition is the same as multiplication, so 2 times 32 is 64. And then you go, oh, I know this one. 4 to the what power is 64?
4.
3.
Darn it.
So then the answer to that is 3.
So what if they have different bases? You can't do
Then
it.
you can't do it, yeah. How about log base 2 of 80 minus log base 2 of 15? Subtraction is the same as division. 80.
It's 5, not
That's
gross.
random. Oh, that is a bummer.
What
Let
is
me
it?
just, how do I do that?
8 pages?
You hit stop instead of pause. So I don't know.
No, it's hit off.
No,
Otherwise,
you hit stop.
no, I didn't.
Yeah, you did.
Oh my
Yeah,
god.
because then
Who
when I
knows
hit,
everything?
then when
I
I
watched
hit,
you hit stop.
okay, if I had hit stop, then when I hit record again, it would make me save it as a new file. And it didn't. Okay, 8 divided by 15 is 16, and 2 to the what power is 16.
4. Beautiful.
Okay?
And what about
What about when you don't know them?
what about when you
I don't know how to do it.
wait,
Then you can't do it.
I'm good with
So you
this
just
right
like
here.
extra it and that's
I
it.
don't have
Yeah,
the
you don't
algebra.
simple
Nice.
What are you doing?
Please.
We'll teach you for 5 minutes stuff that you already
I didn't know
and
this.
give you an assignment.
I knew
We're
it.
gonna have to push you a little bit harder than that.
What is April?
Okay,
We're like 4th graders now.
couple of limits. If you look at the graph of a log function, you should be able to see that as x approaches infinity, what's happening to the graph? It's approaching infinity very, very slowly, but it will get there eventually. So the limit as x approaches infinity is infinity, and then if I approach 0 from the positive side, what is this thing doing? Negative infinity. And then I got nothing going on over here because I can't take the log of a negative number, because you can never raise a positive number to a power and get a negative answer. Sure. Okay, so let's try and do a limit here. Let's do the limit as x approaches 0 of log base 10 of tangent squared of x.
0.
What is that at the
No,
bottom?
because it will move
0.
over and stuff, won't it?
Well, I'm going to go with negative infinity, but I don't know if that's right.
Oh, that's what I meant.
You meant negative infinity.
Yeah.
I don't know what.
What is this?
days.
Okay, so to do this, yeah, that's X.
I tried to go to California Pizza Kitchen, but Mary shot me down.
Okay,
She
refocus.
wanted American food. I'm like,
Refocus.
California Pizza Kitchen. It's 2 states away.
To do this, well,
Did you
next
get
year.
it? Yeah.
Yeah, that's
No.
better than, yeah, that's only one.
They're only 9.
Oh,
Less
so
than half.
less than half, nice job, Mary.
Yeah. Thanks for laughing.
Your face, it was just.
You had this look of disappointment, like, you know, you failed.
Like, oh, no.
No, you walked in
Don't
like,
read too much into
oh, okay, we really, what? All right, what happens to tangent squared as x approaches 0? As x approaches 0, then.
Well, tangent does this.
Yeah, tangent has that weird asymptote thing going on. Yeah, so that's going to approach 0, okay? And then what happens to the log as it approaches 0?
Negative.
It
It's
approaches
the same,
negative
so it's the
infinity.
same.
Yeah, so it's going to be negative infinity.
Isn't that what you said? I don't
Yeah.
like this for dealing with this.
Wait, no,
Um,
wait, go back.
What?
That's all you do? Oh, it's a limit, not a derivative.
Now assignment because we learned something.
Oh, that was so awesome because your face, you have to look of concentration like you're going to ask a really thoughtful question or something like that. And you're like, what? Okay, what I did in the end is I thought about what happens to the graph of the tangent squared of x as x approaches 0. And since I know the tangent graph looks like this, I figured that it was getting closer to 0. Yeah. Okay? Then if this is getting closer to 0, then I looked at this one here and said when that's getting closer to 0, that's approaching negative 0.
So why do you, like, because it's a log of tangent, why do you have to look at two different graphs?
Why do what?
Why are we looking at two different graphs?
Because it's a composition of two different functions.
It is?
Yeah. One is tangent squared of x and one is log of x.
Can you do like a regular one for me? Like a number one? Are you, can you graph it?
No.
So
When one comes up in your sign now. All right, so those are your basic logs. Then we have our old friend, the natural log. So if you, what natural log means is if the base of your logarithmic function is e, then you say, well, log base e of x is so useful that we're going to call that the natural log of
Why
x.
is it natural
Especially
log?
because it
Oh,
comes
because
up
they use
in
it in
natural, in biology.
biology.
Right. Yeah, geology, all kinds of natural sciences, it comes up all the time, okay?
You can
So
model
when you
populations
see
by using that.
natural log of x, you should think of e, okay?
And if you take the derivative
All right,
of that-
so find x if the natural log of x equals 5. So do
Wait,
you
go
remember,
back.
do you remember how to solve natural log equations?
1 second. Put in your
Put
calculator.
e to the 5th.
Good, yeah, because natural log and
Base
e are
answer
inverses. So if
No.
you go,
Stop.
if you put both sides to base e, the e and the natural log will cancel out.
Okay.
And so that leaves you x equals e to the 5th. Okay, so if I make this base e and this base e, the e and the natural log, Raina, can you please put your phone away during class? Then the e and the natural log will cancel out, and so x equals e to the 5th. Because e and natural log are inverses. What?
Like, what is e?
I don't know why they use the letter e.
No.
but-
I mean, like, what?
Oh, e is the limit. Did we not have this discussion in this class? As x approaches infinity of 1 plus 1 over x to the x.
What is why is that significant? Why is
It turns out, strangely enough, that this number, e, this irrational number, is used in a lot of things.
Like,
Population growth a lot of times is a base e. Banking, when you have continuously compounding interest, is base e. Remember
Basically, it's
that
an
PERT
Illuminati.
formula? Yeah, it's Illuminati. And so I don't know why in the world anybody ever decided to study this and came up with this as an answer. And it's really strange that when they did, it turned out to have a lot of useful applications. But that's the same thing as when you say I is equal to the square root of -1, and you go, that's an imaginary number, so who cares? And then it actually turns out that they use that a lot in electronics. So,
Sus.
yeah, it's weird. Yeah, there is a class that you can teach called calculus-based physics. So you're doing calculus and physics at the same time. So
It seems like it would make physics a lot easier.
I think it makes physics a lot easier. I think it makes calculus a lot harder.
Put an example
Because it's
for
all
them.
word problems. Example 4, I don't know. All right, so what if you have e to the 5 minus 3x
So
equals
you can use natural logs.
Right, so now we're going to natural log both sides. So the natural log and the e cancel. So 5 minus 3x equals the natural log of 10.
You don't even have to do that. You can just write ln and then you know the base is e, and you know that 10 is what you're doing in an exponent. Basically.
Then you're confusing. Yeah, you confuse the crap out of your numbers.
Base,
So
and
now what do we do?
Exponent.
X.
So you-
Right, okay, then you subtract 5 from both sides. So negative 3x equals the natural log of 10 minus 5. Yes?
But it's ln 10 minus 5.
Right. Right. This
So
is
you
not,
know
it's
what
not
your
this.
parentheses.
Okay, so put the parentheses around the ln 10. Okay, or do that.
Okay, and then divide that by negative 3. And whatever that is your answer.
So how do I know what
What's
the
the-
natural log of
Put it in
10
your calculator.
minus
Ask
5?
your calculator.
I don't have one.
Is that an acceptable thing to do in like?
I think you can leave it like that
That's
in
the
a lot
only
of
way that
college
you can
classes.
tell. Wait, Rena, what was the one that you said to do it easier with?
It's not.
Negative 3.
Okay,
So it'd be
It's
positive.
not-
It's okay.
so 0.899.
I think.
What? Did you go like this? Did you go natural log of 10 minus 5 divided by negative 3 like that? No?
I got what he got, so.
Can I see?
I'll have it. All right.
I don't remember what's talking about it, okay?
When's the last time you and this algebra went on a date?
Okay, so
Wow.
Where's Gaben?
how about using the properties of logarithms to put these together?
Hey, it's
Um,
Mr.
What?
He's on Instagram.
Okay, will you put your phone on
Mr.
please
Trimble?
also? What can I,
Wait, guys,
what can I do with this 1/2?
put it, as an
So
exponent.
that's an
to b.
exponent, so this would be natural log of a plus natural log of b to the 1/2.
What the
And
heck,
then
why do you do
addition
how
is
multiply
the
them?
same as multiplication, so this would be natural log of a b to the 1/2. Please note that it's only the b that's being raised to the 1/2 power, not the a.
Why is it not the- If you're
Because
multiplying
in exponent land, if you have a power being raised to a power, what do? Multiply and get x to the 15th. So since these are exponential equations, basically, multiplication is like an exponent. And an exponent is like multiplication. Okay? Your other face before was better, that was just like
No, but it's in front. Never mind. I just explained it to myself.
Okay.
Your answer is not
Don't
correct.
know if it's.
It's number 3 on the log thing. See, it's right here.
Yeah, right, exactly. Property number 3 of,
Not in the next one.
okay.
But if you put the 3 in front.
Oh, wow.
Good?
My jaw hurt.
Okay. Then, like somebody said, can't remember who, probably Leanne, and I never gave her credit for it. No, but it was Marina. If there's no base, it's base 10, right? That's all your calculator has. So let's say you wanted to figure out what the log base 4 of 15 was, and you're like, my calculator only has base 10. What do I do? OMG. You can rewrite this as log of 15 divided by log of 4, or you can do it as natural log of
Yeah, you can
15
do either
divided by natural log
Because
of
they
4.
cancel out.
You can choose your base, yeah, it can be any base you want. So if you want to use e as your base, then it would be a natural log. If you want to use 10 as your base, then it would be just regular old log. Either way, you'll get the same thing, okay? Now, if you have a calculator that has the new thing on there, yeah, it gives you an opportunity to put the base that you want anyway.
Hold on. Who has one of those?
It's math log. I think everyone has
Just do
it.
math and then go
Hi
up.
there. Math which?
Math A.
Oh, okay. Give me just 2 seconds, all right? Math which one? 8?
No,
Oh,
scroll
8.
up twice.
Go up twice.
Just scroll up twice.
Oh, aren't you just clever? Okay, then this gives you an opportunity to do the things you
So on the folder, so tomorrow.
So you could do it like that, or if you don't want to go through that trouble, you can go, well, I changed it in the one that I knew the answer to, or you could go division, or you can go natural log,
Is there some
16 divided by natural
means you
log.
can't have a base in it, so you like do that information?
Yeah. Oh, you need some batteries. So either way you want to do this, actually there's 3 options. You can do the change of base on your calculator, or you can do log 5 divided by log 8, or you can do natural log of 5 divided by natural log of 8. The 6 decimal places, what do you get? Too lazy?
So not.
You know how to do it? I don't need to do it. You can figure it out.
0.77,
Yeah.
397.
All right, since the natural log is also a log function, it just has a different base. The limits that were true,
They're the same.
Don't yell at
No, we were
me.
just talking about. Yeah, I know.
I don't have mine.
the limits that were true about the log functions also apply to the natural log functions. The natural log, the limit is x approaches infinity, and the natural log of x is also infinity. I have some startling information about how slowly the natural log of x increases. Would you like to know?
Hey, we learned that last year.
Learned is a maybe too strong of a word.
We heard that last year.
Good old pre-calculus
We
math.
heard that. We heard that last year.
Heard it, that's a better way to put it. Okay, so the 10 basic functions, one of them was the natural log of x, and each one had an interesting fact,
I
right?
remember doing that.
Okay, the natural log of x, also called the natural logarithm function. This function increases very slowly. If the x-axis and y-axis were both scaled with unit lengths of 1 inch, you would have to travel more than 2.5 miles along the x-axis just to get a foot above the x-axis. You have to go 2.5 miles that way to go 1 foot back. So there you go. Increasing, but it's startling, isn't it? Makes you really wonder about your life. Okay, so if you were to sketch the graph of this, all you need to know is that normally it's going to look like this, but it's going to go to the right 2 because of the minus 2 inside, and then it's going to go down 1. What a nice drawing that is. Because of the minus 1 on the outside. You guys remember that hopefully from your transformations of graphs that were pounded into your brain over the course of the last couple of years. Okay? Woo! That looks scary. Don't want that. All right, that's more,
You want to read us the story?
just a second. Now, I will